Welcome, everyone. Midday in this part of the world. It certainly feels as if spring is slowly beginning to come. It's still quite rainy here in the southwest, and I expect elsewhere in the UK, but the days are definitely getting longer, which feels good. Now, this session today is going to be one of complete drawing. We're going to look at the way in which number unfolds through geometry. So it'll be quite simple forms we're drawing, but I'm going to get us to draw it in a particular way whereby we can see a principle of development relating to odd and even, but also relating to the generation of polygon stars. So I'm actually, well, we can get drawing straight away. So I'm going to switch my cameras. And I'll highlight myself. Hello. Now I'm going to try and spotlight myself to, okay. Well, welcome everyone. Yeah, we're going to start drawing, like I say, straight away. We're going to look at the way in which polygon stars develop and how they work according to this principle, I suppose, of odd and even, and how you have a certain number of polygon stars depending upon the particular number that you have as your division of the circle. Right, so I'll switch my camera, my drawing camera on. Well, I'm actually going to be beginning with a piece of A4 in landscape orientation, and then I'll be moving on to A3 in landscape orientation, and we'll use both sides of that. Right, let's begin from the one, because of course that is the beginning of everything. Now, if we're talking about that in geometric terms, I'll just begin by putting a dot. Now, maybe you can see that dot. Perhaps I'll put it just a bit darker. Now, the one in geometric terms is the point. It's the dot. But having said that, if we have this dot, when we talk about, I suppose you could say a circumference and a center. When we talk about a circle, you have a hidden center and a visible circumference. So you actually, in a circle, you have these two things. You have hidden center, and I suppose you could say the visible body of the circle, which is bounded by the circumference. Now, with that, you automatically have the radius as well. So you have three things actually with a circle. Whereas with the point, you just have the one, you just have the dot. But this dot we're looking at here, if we looked at that dot really closely, even that would have a center and a very small circumference. So the point itself, the one itself, is actually beyond our vision. It's not something that can be seen. It has no body. So this dot here just represents it. So let's just leave it at that because nothing more can be said of it. Right, so I shall get my ruler and do the next thing, which is to draw a line. A dot at either end. And we've moved from one to two. So when you have two, you have these 2 points, and therefore you have the line that runs between them. So this is the first dimension because this is actually dimensionless, whereas the first dimension is a line. But the thing about a line, again, this can only be an imperfect sort of representation of a line because a line, properly speaking, again, is invisible, like the point, because it's the invisible point having moved or flowed in one direction. So this also has no body. I mean, it has gone into one dimension, but Euclid describes the line with both affirmation and negation in relation to this, because it has gone into the first dimension, but it has no body. It's invisible. So this one here has a tiny, tiny amount of width and a minuscule amount of height. So this is actually a three-dimensional object, though it's a representation of a line. Right, with geometry, let's actually now move to drawing geometry. Now, I'll show you how I drew these points here, because I did actually do them in a particular way on my paper. Right, first of all, if you can get your compasses and set the radial measurement to 1.5 inches. Right, where I put this dot in the paper, so as I said, it's a piece of A4 that we're working on. I came down, well, I came across 3.5 inches and came down from the top 4 inches. Now, don't worry about it being absolutely precise. Just do that roughly 4 inches down and 3.5 inches in from the side of the paper and put a dot there. Right, so with our points, I've got 1.5 inches on here, and I'm going to use that point to draw, this time draw a circle. Now, as I mentioned before, we're going into the realms of threeness now. So we've done the point on its own, we've done two, which is a line. So now we're going to go into the second dimension, because of course all the geometry we draw on paper are images of two-dimensional forms. Now, with a circle, as I mentioned at the beginning, you automatically have a certain kind of threeness. A circle is really an image of the one, but you have a threeness because you have the center, you have the circumference, and then you have the distance between them, the radial measurement. So you always have this threeness whenever you have a circle, even though the circle is an image of the one. Now, to really emphasize this threeness, what I'm going to do now is put my ruler like so and make one mark above and one mark below, like so. Do that just a bit stronger in case you can't quite see that in the light. Now you'll notice I'm putting my ruler through the center and then using these 2 points like this. Now, perhaps just while I'm at this point, we haven't drawn the thing we're going to draw yet, but at this point, it is quite important, perhaps with all the antagonism in the world at the moment, to recognize that the thing about the center is that it's at that middle point between all opposed views. And so the need for spirituality at the moment is absolutely immense because people seem to be caught up in all of this antagonism of duality and opposites that can't find its middle ground. Right, I'm feeling a bit moony today. Right, I'm doing this. I'm putting the point of the compasses with the same radial measurement that we drew the circle, and I'm going to make a mark like so and a mark like so. Energy always runs higher at full moon. Right, so having got the one at the top and these two ones here, I'm going to give us an image, a geometric image of threeness. And this is the most simple form that you can have in 2 dimensions. I suspect you recognize it, find it familiar. So when you just have the one, you have no thing, no visible thing. When you have the line, you have, well, this potential for, I suppose, proximity between 2 points. But once you get to having 3 points, then you have body in the sense of you have something that can be seen. Now, the thing that I want to emphasize about this, because this is what's going to come in relation to the sequence of forms we're going to draw in this session. I'm just going to continue the edges of this triangle um, in all directions. This is just really to make a point. It'll sort of link in with what we're going to be looking at very shortly. Now, the point that I want to make here is that all of these lines, you can see they're all going off in different directions and they're never going to meet again. So the relations that we have are these 3 points, and then the lines just move off. Now, this may sound like a slightly arbitrary thing for me to point out, but a little bit later on, you'll see why I've pointed out, because this sort of comes in when we understand the way that polygon stars develop within these geometric shapes that we're drawing. Right, so I'm now going to use the line here. I did actually draw this line a particular distance from the edge. Again, it's um, 4 inches down from the top, and just draw a line through there from 4 inches down from the top of the paper. And I'm using the same radial measurement of 1.5 inches. So basically you need to have, well, this circle I drew, so yeah, 3.5 inches away from the side. It just makes it sort of sit nicely within the paper. So that's another way you can do it. You can draw a circle that's 3.5 inches in from the side of the paper, 4 inches down from the top. Now, you guessed it. I'm now going to do an image of 4. So same radial measurement on the compasses as what we've drawn the circle with. I'm putting in these 2 semicircles. And then I'm going to put in a bisector cross, one above, so using those 2 points there, and one below. If you're drawing accurately, hopefully you should find that your line goes through the midpoint, your vertical line there. Now, as you see, I'm going into the top point of the circle that we've established through putting in the vertical line. And I'm now going to go into the southern point, as it were, of the circle. And I'm going to put in these diagonals going between the tips of the petals. And so that gives us the particular square that I'm going to use. We could have used a diagonal square, but I wanted to use one sitting flat on its base. Now, another thing that I should point out here is in relation to odd and even. The Pythagorean way of understanding number would be that usually the odd is masculine and the even is feminine. So the way we're going to work is having odd number and even number as we go on from here. Now, the 1, that's perhaps one of these exceptions to the rule, because the 1 is both masculine and feminine at the same time. But at the same time, we could also say that 1 is odd and 2 is even. And of course, 3 is odd, 4 is even. So clear to see. Right, so I'm going to draw a square inside the circle like so. So we've moved from 3 to 4. Now, with 4, we could actually have gone into the third dimension. So if you can imagine that this is the triangular base of, well, a pyramid, let's say. It is often called a pyramid. And then imagine if there's a floating point up here, which has 3 triangular faces going up to it, like 3 faces of a pyramid. That's what's called a tetrahedron. So that's the most simple 3-dimensional form. And that's what you need for 3 dimensions. You just need 4 points, 1, 2, 3, and then this one above, which is 4. But what we've done is obviously we've gone into 4, we've remained in 2 dimensions. Now I'm going to, again, emphasize what I emphasized with the triangle. I'm going to put some dotted lines here, just to emphasize that the edges of this square, they would just carry on indefinitely as they move away from one another. Now there is a certain regularity that comes about when you have the square, because as you'll probably see, what these angles that are created here are right angles like these. And what we'd have here, so you could just surround this with lots of squares. Whereas with this one, the triangle would be surrounded with hexagons. So that's a hexagon there coming off. That would be a hexagon and triangles. So there's this sort of uniformity that you get to when you get to the square, in the sense that it's surrounded by lots of other squares if you extend the lines. But with both of these, we still don't have any polygon stars that naturally develop. I mean, you can put a particular type of point on here, and that would be sort of deriving from an 8-pointed star, but you can't really get polygon stars from these 2 shapes that sort of naturally develop, because their lines, as they go off, they just go off forever and don't meet again. Right, all of this that I've been talking about, 1, 2, 3, and 4, this is sort of the groundwork. But from now, we're going to start to actually draw the polygon stars. And so you'll see why I've gone through all of these various, maybe seemingly slightly arbitrary details. And I'll probably come back to this diagram shortly. Right, I'm now going on to A3 paper. And as the numbers go, I'm going to move on to the number 5. Right, let me just remind myself of the measure I'm using. Right, so I'm going to make a mark 6 inches down from the top of the paper, right on the edge on the left here. I'm going to make a mark here, and then I'm going to come in. You can just use your eye to make sure that you get it. Now it's 4.5, so that's where we want to have the dot. Yeah, so the dot here is 4.5 inches in, 6 inches down. It just centers it within the paper. It puts it on one side. This is going to be the odd number, number 5 and the number 6. Right, so again, 1.5 inches on the ruler for the radial measurement of the compasses. And I'm going to go into that dot, 4.5 inches from the sides, 6 inches down from the top, and draw a circle. And in goes a horizontal line. that passes through the center of the circle. Right, going into the eastern point of the circle here with the same radial measurement, I'm going to make a small mark, one above and one below, and also the equivalent thing from this western point of the circle as well. Right, I'm now going to put in a bisector cross. Now I'm going to put in 3 vertical lines, one like that. Now this time I'm not going to put lines in actually, I'm going to just do a slightly edited form. Rather than putting in a whole line between these 2 points, I'm just going to put in that mark there. It just sort of cuts down on the amount of lines that we have. Because this is the only part of these 2 vertical lines. Just that's all we need really, just those 2 bits there. Now, if you're used to drawing or dividing the circle up into 5 and 10, you'll know exactly what I'm doing here. So I've used that point to place the point of my compasses to draw a circle here. Now we want the circle to go through the center of the big circle and the circumference point of the big circle. So you need to make sure that the point of your compasses is at the midpoint between there and there. So, you know, what I'm saying is that if your line that this mark you've made here is slightly off, then feel free to move the point of your compasses ever so slightly if you need to get it in the right place. Now I'm going to actually do the upside down V in this particular instance. Now this number 5 we're working towards, which of course is the pentagon, I'm going to actually do an upside down pentagon because of the way in which it'll interact with the polygon star that I want us to draw. So having drawn that V shape, upside down V, we need to get this measurement on our compasses. So point in the northern point of the circle, point of the compasses in the northern point of the circle, and pencil there where the V goes through the small circle. And in this one goes. Now, if you've managed to see the last session that I did 2 weeks ago, I only just put it up a few days ago onto YouTube. I talked all about the square root of 5 plus 1 and the square root of 5 minus 1. So that's sort of showing how the golden ratio shows itself in this particular diagram. Right, having put in that arc, I'm now going to extend to this position here. One mark like that, one mark like that. Right, I'm going to put in the five-fold polygon. I'm actually going to do it upside down. So that's the baseline, you could say. Now make sure you get the correct point, because obviously these 2 points are close together. So make sure you use the correct points for this. And there. So this little line that we drew like this, it's where this line meets the circumference of the big circle. That's the point I'm using. So that's the point that I've just used there. Right, so we have the pentagon like so. So we've gone from the 1 to the 2 to the 3 to the 4. And as I showed you, in these instances, the lines, the way that the lines, for instance, of the square are angled are such that we'll have these lines continuing off like so and not meeting again. Now, what happens when we get to 5? Suddenly something changes. And whereas with the first two numbers we looked at, 1 and 2, there's nothing. There's no body, as it were, no visible form. And then with 3 and 4, we do get something, but we just get a polygon, and that's it. So with those ones, we do have body, but just a single polygon. Now, when we get to 5, we have this new possibility that comes in, which is a polygon star. So these two lines, if they were to continue, they would then meet again up here. So that's what I'm going to do next. Now, run your ruler very carefully along the whole of that edge. Make sure you're doing it accurately. You can probably see roughly when you get to the midpoint above there. And likewise here. Now, there's going to be a lot of working by eye with what we're doing here. So I'm going to continue this line as it goes, but I'm going to look along this line at the same time and see roughly when I'm going to meet that. So a certain amount of sort of trial and error. Like I said, I'm wanting to do this just so that we can get a sense of how these stars develop. And so we can get a sense of how they do actually extend out from the polygon in the middle. And so in this sense, these stellations, they're sort of emanations, you could say, from the polygon. Oh, it's 12:30. It's full moon right now. Right, so having done the odd number, we'll now do the even number here. And we can do, yeah, same measurements. 4.5 inches in from the sides and 6 inches down from the top. Now this time, for the division of the circle, I'm going to use a 2 inch radius. So this circle is a bit bigger. And I'm going to do that diagram that you can see all over the world, lots of different places. It's probably the most fundamental diagram that you can draw with the circle. You just walk your way around each new position on the circumference that you create for yourself. And I'm going to join up the tips of the petals so that I get the next polygon, which of course is 6, the hexagon. Now, this principle that we're looking at of the development of polygon stars, they always go in pairs of odd and even. So in the way that this is a single polygon, which then gets one polygon star coming forth from it, that is the odd one, whereas the even one is 6. And this happens in the same way. You just get one polygon star that comes from this particular polygon. And if you do geometry a lot, you'll be very familiar with this form. Made up of 2 triangles There is a principle of prime numbers as well when it comes to drawing um, these stars. The fact that the six-pointed star that we're drawing at the moment is made up of two separate triangles. That means that it isn't a prime number, because of course 6 divided by 2 is 3. And that's essentially what's going on here. It's two triangles, so two threes, which together make 6. So this is the visual demonstration that 6 isn't a prime number. With prime numbers and polygon stars, if you have what would be called a unicursal star, such as this, if all you can get is unicursal stars, then it's a prime number, because you can't have, two separate forms that together make the star. It's just one line going over and over. You can get unicursal stars with non-prime numbers, but all you can get from prime numbers is unicursal stars. Right, so we're just going to do two more, and that'll be enough really to show the principle. So, like I say, we started with 1 and 2, which gave nothing, or nothing we can see. 3 and 4 gave a polygon. 5 and 6 gives a polygon and one polygon star. Right, let's turn over. And in fact, I'm going to actually put the hole in the center through there, like that. Just that one, actually. Turn over. Right, because of the way in which these stars expand, I'm actually going to do a really odd measurement, so you'll need to listen closely. 1 inch is made up of little sixteenths, so we've got 16 little parts in 1 inch. Now I'm going to set the radius of my compasses to 15 sixteenths. So one tiny little increment before the 1 inch mark. That's what I'm setting my radius to. Now I'm using the division of the circle into 7 that I used in an earlier session. It's one where we just do 13/15ths of the radius. So that's the reason why we're using this slightly out of the ordinary number. Right, so again, this point that I'm going to draw this small circle from is 4.5 inches in and 6 inches down from the top. So working at quite small scale for this particular one. This is what happens with the 7. Right, so having drawn my circle of 15/16ths of an inch, I'm now going to reduce my radial measurement by 2 increments to 13/16ths. Right, I'm going in at the top, like so. So the little vesica that I've drawn doesn't quite reach the center. And I'm going to go to this point here where the vesica reaches the circumference. I'm going to gradually work my way around. I'm actually going to now go across to this point here. Not actually possible to divide a circle up into 7 in a 100% type of way. 7 is this very elusive number. Now, when we draw at this sort of scale and we link up points, we need to make sure that we're working very accurately indeed, because it's quite easy to go off. This isn't the usual way I would draw a 7-pointed star, but it's just useful for sort of showing these polygon stars and how they emanate out from the center. So very carefully put in, make sure it's very accurately going from point to point, this heptagon that we're going to draw here. I talked about the number 7 in one of my previous one of these sessions, and how the Pythagoreans described it as the number of the Virgin. I won't go into detail with that because I've done that in a previous session. Right, now it's with this one and the number 8 that we're going to do in a second that you'll start to see the principle that I'm describing really showing itself well. Because what I'm going to do is first of all extend the lines in a similar way to how I did with the previous diagrams. Just going to, as you can see, I'm sort of extending all the lines in both directions. It's just a slightly quicker way of doing it. So this is the first emanation, you could say, from the 7-fold polygon. So we have a polygon and a polygon star that we can get from 7. But as you're probably seeing, we can actually get another polygon star as well. And this really is the principle that from now on, every new odd and even number will be able to get one more polygon star on each occasion. But just by extending these lines out, you eventually find another relationship. This, of course, is the last relationship that all these lines will have. I want to have a rubber to hands. Now mine's gone a little bit irregular. Such is the case when you start from a very, very small point in the middle there. You'd never really draw a 7-pointed star like this, but if you did, the way to make it regular is so once you've got one point, you can then draw a circle, and then you can at least make sure that all your other points remain within that circle. So yeah, very difficult to make something accurate if you begin from a small form in the middle and then move out. Right, now the final one is 8, obviously, and I'm going to use the whole from the center of this one, like so. And the radial measurements that I'm going to use is back to 1.5 inches. Now we're going to go through the same division of the circle as what we did for the 4. Now these diagonals that are now going in, they give us the other 4 points to go with the north, south, east, and west. That gives us these ones here. And I'm going to put in the octagon. This is a dynamically orientated octagon, which means it's looks like it's turning rather than sitting flat on its base. And the same way as this has polygon, first polygon star, second polygon star, I'm going to do a similar thing with this. I'm just going to put in the first polygon star first, which is made up of 2 separate squares, because the number 8 also isn't a prime number. It can be 2 times 4 is 8, and so 2 squares make an 8-pointed star. There's 1 square, And in the same way as these lines that are moving in this direction, you can see they're going to move forward and create another point. That's what's going to happen here. Now, interestingly, as I just said, with non-prime numbers, you do still get unicursal stars which just weave around without being made up of more than one form, in the way that these two squares make an 8-pointed star. So you can get unicursal with non-prime, but with prime numbers you can only have unicursal stars. Now that is a 4-pointed star, but you need to derive it from an 8-pointed star, if you see what I mean. So it's not naturally occurring in a four-fold polygon. But it is a four-fold star that you get in Islamic patterns. There's a particular type of 6-pointed star that you can get as well, which derives from a 12. Right, now, if we were to actually carry on, so if we were to then go to 9 and 10, the next odd and even number, the principle would just carry on. So you'd end up with a polygon and 3 polygon stars. So those of you who do a lot of geometry, you'll be aware that there are 3 different types of 10-pointed star. And then when you go up to 11 and 12, then you have 1 polygon and 4 polygon stars. And so on. So that's the principle. And it always works via this odd and even. So the odd number is the one that gives you the next level, as it were, the next number of polygon stars, and then the even number replicates that in slightly different form. We've done that. Right, there's still a few places left on my course in Wales. I've just found out in the last few days that we're going to be constructing a labyrinth outside the west front of the cathedral here in Wales, and that will be on Easter Saturday, which traditionally that's really what the labyrinth in a Gothic cathedral means. It relates to the idea of the descent into the underworld on Holy Saturday. So if you're free to come on any of this course, then do let me know. Now, the next session is going to be on a Sunday morning. Now, the new moon is actually at 9 a.m. So we're going to begin at the time of the new moon. So I didn't feel as if I could rightly get people to be ready for 8:30 on a Sunday morning. So that'll be when the next session takes place. Now I shall back to my camera. Right, well, everyone, I hope you've enjoyed the session today. Do come to the next one on the new moon, 10th of March, Sunday, 10th of March at 9 o'clock in the morning. And I hope you have a good 2 weeks. See you next time.
Thank you very much, Tom.
Bless you. Thank you.
Thank you.